Hello, we are the EECS 373 Keyboard Gloves Group. I am Alex LeBurge, and also in the group is Meredith Monticello and John Connolly. We have created a device that allows you to mimic typing on a keyboard to produce the same keystrokes on your computer that you normally would, but without a bulky keyboard peripheral. Here's a photo of the final prototype. As you can see, the flex and pressure sensors that are mounted on the fingers are connected to a hub on the back of the hand. The hub is connected with both wires and wirelessly to the Smart Fusion board, which is controlling all of the logic. Control bits for the hub's analog multiplexer are sent wirelessly through an XB, and the output of the MUX is sent back over a wire to the Smart Fusion board to be processed. Here is the base station. As you can see, we have an XB mounted along with a Smart Fusion board. The Smart Fusion board is the device that is sending out the control bits, and the XB communicates them wirelessly. Next, onto the software. We take in those flex and pressure sensors data into the ADC, which provides digital values that we can use to set thresholds for different keys. Each finger has a bottom row, middle row, and top row. Once the board detects a finger press, it takes in the flex data, determines a row, and outputs the character at that row. Next is a video of the gloves in action.
The software is currently limited by timing constraints. Data values from the hardware took too much time to be read reliably and processed. From this restriction, our current threshold values for a keyboard character only rely on the value of one flex sensor. By optimizing our data flow, it may be possible to pull all the flex sensor data for a single key press. From that, we could add threshold values for the remainder of the keyboard.
Due to time constraints in the project, we were not able to implement any machine learning. With more time, we would have implemented a calibration mode, where the user could type on a keyboard synced with the keyboard gloves. This data would be used to alter the hard-coded calibration values to something more user-specific. This more personalized profile would then be stored, and the user could use this profile at a later date for a more pleasant typing experience.
One of the cool parts of this project is the modularity of the design and the expandable nature of this product. More software can be developed to aid calibration and to implement different typing styles. Also, with this modularity, we can get more accurate readings through better sensors without having to change any of the circuitry on the hand. Given more time, one of the functions we'd like to better implement is sending our flex and pressure data over XB rather than over wire. This results in us having to decode a PWM, something that can either be done over an RC filter or through a PWM reader. Our RC filter was far too slow to pull all of the fingers like we would have originally liked, and our PWM reader had a lot of noise, which often gave us poor flex values. Given that we could improve on one of these features and implement battery power for the hands, a completely wireless product would not be too far away. Thank you for watching.